Hello everyone, this is our project, the Handwritten Number Recognition System developed for our Intelligent Systems project. Our team members are Abdur, Sajaan, Shavini and Randima. The purpose of our project is to automatically recognize handwritten numbers using machine learning and computer vision. In today's world, handwritten number recognition is used in many real-world applications such as bank check processing, postal code recognition, and digital form automation where handwritten data must be read quickly and accurately. Our project works in four main stages as pre-processing, segmentation, model prediction, and GUI interaction. The overall project flow starts with dataset collection, followed by pre-processing, segmentation, training ML models, testing, and improving the system performance. We focused on developing a system that is accurate, interactive, and easy to use. The final outcome of our project is a fully functional system capable of recognizing handwritten digits from 0 to 9 with high accuracy.
We worked on three different data sets: the MNIST database, the SVHN database, and the EMNIST database, which is an extension of MNIST. All the images were resized to 28 by 28 pixels to match the MNIST format to ensure the consistency across the datasets. We experimented with various techniques, including grayscale conversion, uh, clash, which is like contrast limited adaptive histogram equalization, threshold morphology operation, and deskew. After extensive testing, we found that grayscaling conversion combined with normalization and resizing delivered the best performance, offering the highest accuracy, noise reduction, and compatibility with all three machine learning models. The next stage of our system was segmentation, when we separate multi-digit images and the individual digits using three methods: contour detections, which traces each digit's boundaries; connected components, which identifies the pixel region belonging to each digit; and the project profile, which analyzes the vertical pixels and density to find the digit gaps. Since the handwritten style and the digital space varies in each segmentation method, performance and differences, hence our system allows the user to test all three approaches, as you can see on the slides. Additionally, we developed an auto selection feature in which the system analyzes the images and automatically selects the segmentation methods and yields the highest uh, recognition of accuracy, thereby improving the reliability and the efficiency of the models and removing any kind of manual choice.
Hi, I'm Randima. I'm going to explain about machine learning models. Choosing a machine learning model is one of the crucial part in this project. For digital recognition, we use three models: CNN, SVM, and random forest. The CNN automatically learns image feature and spatial patterns, giving the best overall accuracy. The CVM separates data into classes using the optimal boundary, performing well on small and clean datasets. The random forest combines multiple decision trees to make quick and stable predictions. We selected three models because they represent different learning approaches: deep learning, margin-based learning, and ensemble learning, which allow us to compare their performance and understand the trade-off between complexity, training time, and accuracy. All models were implemented in Python using TensorFlow and scikit-learn libraries. Testing multiple models help us evaluate which one performs best for handwriting digits. The CNN achieved the highest accuracy, which I will describe later in this video with some test cases. Next, Sajaan will demonstrate the project GUI. Thank you.
Here is a quick demonstration of our handwritten number recognition system. When we run the program, the graphical user interface opens from here. Users can either upload a handwritten image or draw digits directly on the canvas. I'll go ahead and draw a few digits to test the system. Before running it, we can select how we want the image to be segmented. The system supports three methods: contours detection, connected components, and projection. There is also an auto-selection mode that automatically picks the best segmentation method based on the accuracy. Next, we can choose which machine learning model to use for recognition: CNN, SVM, and random forest. Each model was trained on handwritten digit dataset, and you can easily switch between them to compare performance. Once we hit run, the system displays two main windows. The preprocessing window. Here is the preprocessing window. The preprocessing window shows how the image is cleaned and standardized before analysis. And then this is the segmentation window. The segmentation window visualizes how each digit is detected and separated for recognition. Finally, the result window shows the prediction results along with model accuracy. For this example, the auto selection mode has selected connected components as the segmentation methods, and also the digits are recognized separately and their accuracies are also mentioned. When testing across different models, we found that CNN consistently produce the most accurate results, followed by SVM and then random forest. This allows users to clearly see how model selection affects the performance. So that's our handwritten number recognition system. Now Shavini will continue from here to explain how the accuracy works.
I will be showing the accuracy levels of each frequency model and each segmentation method we have used. As you can see, I have already drawn an example and it has already displayed the output. When I click on compare all models, we can see the model comparison results. Through this, we can compare all three models and see that the average confidence of the CNN model is higher than the average confidence of each of the other two models. When we compare the segmentation methods, we can see the segmentation method comparison. Through this, we can see the segmentation method average of connected components is higher than the other two segmentation methods. Thank you.
For the research component of this project, we implemented handwritten match, expression recognition, and solver system. So this is the graphical user interface that we created. For the segmentation method, we use smart components, and for the machine learning model, we only use CNN. This system supports digits from 0 to 9 and also match symbols like plus, minus, multiplication, division symbols, and also brackets. As you can see, all the symbols are recognized in this system. Then let's try a match expression. Here is a basic match expression. So for this expression, first we have to get the total of 8 plus 4, which is 12, and then 12 times 2, and the final answer is 24. So this shows that the system also follows the BODMAS theory. And this is our final project.